In this class, I want us to investigate this vis-a-vis this. If they mean the same thing, if there are differences, we are going to look at that in this class. Okay? This is a continuation of where we stopped in our last class. So if you have not watched the first video on calculus, go and watch that. Okay? But because I'm thinking this class might span across maybe 2 videos, I decided to put here part 1, okay? Because we might have part 2. Okay? Let's see. We said if this is y-axis and this is s-axis, and we have something like this, we take a point here, say P. We take a point here, say Q. Then we draw this. Then trace this here, trace this here, trace this here, trace this here. We say that here to here, that is here to here, the change in y. Here to here is change in x. That was what we saw in our last class. Then we further said that this over this is calculating the gradient of this line. Okay? That is the change in y over change in x. Then we said limit as this tends towards 0, we represent all this by the y over the x. Now, this was just given to you to believe. We want to investigate if this is true. Okay? As you can see in this place, I've gone ahead, I draw this out because I don't want to waste our time drawing different diagrams. Now, let's say somewhere here is 1. Somewhere here is 1. Okay? I know it's not perfect, okay? Just understand what I'm doing. Now, this line is called a slope. Okay? What we want to do here, I want to calculate gradient. The gradient of what? A slope. This is a slope. We want to calculate the gradient. What is gradient? Gradient simply means a change in y over change in x. Okay? Remember, as I said earlier, these points are considered to be very close. In our last video, the point that is, this one you are seeing here, assume here is our point P, here is our point Q. We consider them to be very close, but we are doing this expansion for you to see it clearly. Now, if I want to get the gradient of this now, I come to this place to get the gradient. That is, here now, you agree with me that this point, if you trace it here, it is 2.5. Okay? If you trace it here, it is 2.52. Okay? This one too, if you trace it here, is 3.5. If you trace this here, is 3.5. Okay? Now, if you want to get the changes, this point minus this point. Also for this minus this. So let's do it. That is, this is equal to 3.5 minus 2.5. All over the same thing. 3.5 minus 2.5. You agree with me? This is 1 over 1 equals to 1. Okay? That is the gradient of this slope. What I want you to do now is, let's assume we are taking this point this time. We are going to use this and this. That is, we are going to change this position of P. Say our new P now is this and this. Let's remove all this one. This is P, this is Q. Let's also calculate the gradient. The gradient is change in y over change in x, which is equals to, this is Q. This is Q. For y is 4 versus 2, minus 2. For x is 4 minus 2, 2. 4 minus 2, because this is 2. This is 4. Again, this is now 2 over 2, which is 1. As you can see, whether we take the calculation from here or here, even if you reduce it, the answer will continue to remain 1, 1, 1, 1 throughout. That is change in y over change in x. Now, let's look at this. This gradient I want to calculate now is for descending slope. Okay? Now, we are going to start, say we calculate it from here. That is, this is our point P. This is our point Q. Okay? And you agree with me is change in y over change in x equals to, we started this slope from here, we went down. That means this is the beginning of the slope, this is the end of the slope. And you agree with me, whatever I say minus this, all over whatever I say minus this, what is here is the last one. You can see in this place, what is here is always the last one. The last one, okay? So therefore, if we go to Q now, you agree with me for y of this Q is 1. Then for S of the Q is 4. Let's go for P. For y of this is 3.5. Y for S of it is 1.5. Minus, minus. You work on this now. You agree with me this is minus 2.5 all over 2.5. This divided by this equals to minus 1. So you can see it's negative going down because it's descending. If we decide to move this point P now, for instance, okay, now we want to use this point for P, this point for Q, this one. Okay, we want to use this one, okay? Let's see. Change in y over change in x. Let's start from the last one because we are going down. This is the last one. At this point, y is 1.5. S is 3.5. Minus, we come to this place, y is 3. If you go down here, that is 2. Now let's see, what is this? This is minus 1.5 all over 1.5. If you divide that, also minus 1. So you can see, the slope remains constant. Whether you take it between these 2 points, between this point, the slope will continue to be minus 1, just as this one was 1, 1, 1, 1. That is what you find for straight line slopes when you are calculating their gradient, okay? How do you handle this when it comes to curve? This curve could have been something like this too. Could have been something like this too. Could have been any curve. These are what? Polynomial curves or quadratic curves, okay? Could also be sine curve, cosine curve, and so on and so forth. If you are asked to calculate the gradient, how do you tackle it? Because now it's not a straight line. This is no longer a straight line. That is the issue. How? How do you do it? Please make sure you watch the previous video before you continue with this class. How? Now, let's continue with change in y over change in x. Please note, this change in y over change in x can also be represented as change in y over change. It's like you are writing 8, okay? Change in x. So these are the same. In case you are looking at the book and you see this, know that what they are talking about the same thing. Now, because we reserve these guys for a straight line, what are you going to use for curves? Because the reason for differentiation and integration are mainly because of curves. Because life is not straight. There's nothing that is straight in this world. Life is curved, bent, a lot of upside down. For a plant that is growing, you don't expect the plant to grow straight. That is what? Perfect straight line slope. Or when somebody is sick, the sickness maybe is descending perfectly. No. Descend today, improvement, descend today, there's gallops. So there's always going to be curves. The reason why we also want to check or investigate or also learn how to calculate the gradient of curves. So I can call differentiation as the calculation of what? The gradient of curves. That is the foundation of what? Of differentiation. Gradient of curves. How you do this is,